Hey, geometry students, welcome back. What we're going to be doing is taking vectors and doing what's called vector decomposition. We're going to break them down into their x and y components. We're going to say that this is vector d. It has a magnitude of 100 and makes a 55-degree angle with the horizontal. All right, we're going to do some vector decomposition. Now, by the way, one thing to mention is that anytime vectors give an angle, it's always measured from the positive x-axis counterclockwise. So you always start with the horizontal axis on the positive side, and then we count up counterclockwise from there. 55 degrees. And we're also going to note that our little segment here is 100 units long. 100. Okay, and we've got our original vector. Now, to decompose this vector, what we're going to need to do is turn this into an x component and a y component. In other words, I need to figure out what goes in my vector notation for this vector, because normally we're used to writing out vectors in angle brackets, and the first number is the x component direction, comma, the y component direction. Okay, and if I could figure out what goes in these two coordinates here, I've decomposed my vector successfully. So how do we do this? Well, first of all, I'm going to draw a vector starting at the tail of the first and going perfectly horizontally as far as this vector goes over. And we're going to add an arrow to that to make it an actual vector. And then I'm going to draw a second vector going straight up from there. Okay. And I'm going to put an arrow on there too. So this vector here is made of the sum of two component vectors, a horizontal vector and a vertical vector. Can I find the lengths of the horizontal and vertical vectors? If I know the resultant here, I sure can. And the way I'm going to do it is by using sine and cosine. So I'm just going to note that the cosine of 55 degrees equals, let's see, what is the ratio of the adjacent? Let's see, it's going to be the adjacent side and the hypotenuse on a right triangle. So in this case, I don't know the adjacent side. I'm going to call it x, but I do know the hypotenuse is 100. Hey, can I solve this for x? Easily. It's just going to be, I multiply both sides by 100. 100 times the cosine of 55 degrees equals x. I got x on a side by itself. All I need to do is 100 times the cosine of 55. So I'm going to look up a calculator. Not calculator soup. Calculator. There we go. All right. And we're going to do 100. Okay. Let's just see if I can punch that in here. 100 times the cosine of 55. I'm going to make sure I'm in degree mode here. Okay, that should be it. Let's do that math. 57.35, 57.4, we'll say. Okay, so that means that x, my x component, is 57.4. Now let's just take a break for a second and think about that. Would I expect it to be about half of 100, a little more than half of 100? Now keep in mind, in a right triangle, things work a little bit differently. I'm not just going to add this number and this number to get 100. I'm also going to notice that if this is a 55-degree angle, this is going to be a pretty steep triangle here. So this side is going to be a little shorter than this side over here. So I'm going to calculate for the other side now using the sine, because that's the opposite side from my angle. I'm going to note that the sine of 55 degrees equals y over 100, the vertical value over here over 100. And I'm just going to note that if I'm doing this right, and it looks like I'm envisioning, because 55 degrees is greater than 45, so that means it's a steeper triangle. This side over here should be, and let me think about this. I think I said that this side was longer at first, and that's incorrect. This side should be a little longer than 57.4 because it opens to a steeper angle. This angle up here is only 35 degrees, which should open to a smaller amount. Let's see if that holds true. So we're going to do 100 times the sine of 55 degrees equals y. 100 times the sine of 55. So all I need to do here is change this 100 times the sine of 55 degrees. Let's see. I wasn't sure whether I had to type 55 first. Let's try that one more time. 100 times the sine of 55 degrees, 81.91. Wow, this side was much longer. 81.91. Let me make sure I rounded correctly. 81.92. I did round incorrectly. 92. So I would say that this vector has a horizontal component, an x of 57.4, and a y. I see now I only rounded to the tenths. 81.9, and that is my decomposed vector. Now, let's see if we did this right. Did I correctly decompose it? X component, 57.36, 57.4, 81.9, 81.92. That is the correct way to do it. You could write your answer like this, or it's also correct to just write your answer like this. That's letter A. Let's move on to B. They do get a little bit harder. In letter B, I have vector P making a 35-degree angle with the horizontal and vector Q making a 40-degree angle with the horizontal. P has a magnitude of 30 and Q has a magnitude of 40. What is the angle and the magnitude of the resultant when P and Q are added? All right, so let's decompose P and Q individually. So here's P. Let me add an arrowhead to that. Okay, P is going to be made up of two vectors, a horizontal vector. Okay, let's try that one more time. There's going to be a horizontal vector here and a vertical vector here. Okay, now I know that's pointing to the side a little bit. Let me see if I can fix that. What we'll do is we'll just grab the bottom and try to make it as even as possible. One thing I need to do with these is make sure they have their arrowheads because they're vectors. Okay. And now I'm going to note that I know this angle and I know the hypotenuse. Okay. I know this angle down here is 35 degrees. And I know the hypotenuse of this thing is 30. Okay. So we're going to note 35 degrees here. We're going to give the hypotenuse a length of 30, and then we'll be all ready to go and solve this. All right, now I'm going to work this the same way as the previous one, but I'm just going to share with you a little secret. And you're going to learn this in physics too. If you know the resultant vector and you're looking for the x component and y component, it's always going to work out the same way because it's always going to be set up like we set this one up. It's always going to be the hypotenuse times the cosine of our angle for the adjacent side, and the hypotenuse times the sine of our angle for the vertical side. And that's going to make these ones really easy to solve. So for this first one, it's just going to be 30 times the cosine of 35 degrees is going to give us our x, our horizontal side, our x component. Okay, let's go ahead and plug that in. 30 cosine, so 30 times the cosine of 35 degrees gives me 24.57. 24.57. So we're just going to write that answer in here, 24.57. Next, we're going to do the vertical component, which is just the sine, 30 times the sine of 35 degrees. Okay. And when I do that, let's just go back and we'll change it. It's going to be 30 sine 35 degrees. 17.21. 17.21. Okay, so I'm just going to note that these are the x and y's for this triangle. Now, without even drawing the second triangle, because I know the angles, okay. And let's see. So Q is a 40-degree angle with a magnitude of 40. So I'm just going to do 40 times the cosine of 40 degrees. Okay, that's going to give me the first value for Q. And then I'm going to do the same thing for 40 times the sine of 40 degrees is going to give me the vertical component. Do you see how easy this is? And it's all because when I simplify this equation, which we very carefully set up down here, it always just turns into the hypotenuse times the sine of the angle gives me the other side that I'm looking for, the opposite side. That times the cosine gives me the adjacent side. All right, so we're going to do 40 cosine 40, 40 sine 40. So we'll plug that in, 40 times the cosine of 40. The x component is 30.64, so let's type that in, 30.64. The y component is 40 times the sine of 40. The sine of 40 gives me 25.71. 25.71. All right, now I've got my x components and my y components. I need to find the resultant. And it tells me that I need to find the angle and magnitude of the resultant vector. Okay, so let's do this. We're going to put these in vector notation, 24.57, comma, 17.21. And then 30.64 is the horizontal of the next one, and the vertical of the next one, 25.71. I'm going to add these vectors together. Okay, that's how I get the resultant. And when I add them, let's see, I could probably try to add here long form. This is going to be 1, 11. I'm going to carry the 1. 6 plus 5 is 11, plus an additional 1 is 2. I carry another 1. 4 plus 1 is 5. I've used up all my carried 1s. 2 plus 3 is 5. This should be 55.21. And then on the other side here, if I add these are going to be a little easier to add. Just 2, I have nothing to carry. 9, nothing to carry. Bring down my decimal point. 7 plus 5 is 12. We carry the 1. And then 2 plus 1 plus 1 is 4. So the resultant of these two vectors added together breaks down into 55.21, 42.92. Now, the magnitude of this. Well, if I think about it, this is just a right triangle with an x component, 55.21, and a y component, 42.92. To find the actual magnitude of the vector, which is going to be a diagonal like this, I have to take the x component squared plus the y component squared and take the square root. So it's going to be 55.21 squared. Let's type that in. 55.21 squared plus, let's see, the next one, 42.92 squared, 42.92 squared. And then actually I need to take the square root of all of this, 69.93, 69.93. So I'm going to say that my magnitude is 69.93. All right, so if I'm saying that this bottom vector here is 55.21, and this vertical vector over here is 42.92. Am I able to figure out what this angle here is? Well, yeah, I can using what I know about sine, cosine, tangent. Let's see, I know that that angle is going to be equal to, let's see, actually, let me think. The tangent of that angle would be equal to the opposite side, y, over the adjacent. Now, I'm just going to fill in numbers right away. Y is 42.92 over the adjacent 55.21. Okay, the tangent of that side is 42.92 opposite over adjacent. Now, I'm going to take the inverse tangent of both sides of this. That undoes the tangent from the left and gives me the inverse tangent of what's on the right. So what I need to do is find the inverse tangent of 42.92 over 55.21. Let's go ahead and do that. The inverse tangent of 42.92. So we do inverse tangent of 40, let's see, what was it? 42.92 over 55.21. I cannot remember these numbers. There we go. 37.86 degrees. So my angle is 37.86 degrees from the x-axis. Let me just make sure. 37.86. Okay, let's make sure we did that one right. Lots of steps, but there we go. We solved it.